Welcome to Spring LIB.
This is the answer to Chapter 31, problem number 14 from the Smith Organic Chemistry textbook. And we're told that a particular polymerization reaction can result in a mixture of products. And we're asked to draw a mechanism that accounts for this mixture of products. And so the first thing in this mechanism, since we know it's going to be radical, we should start with the formation of the radical. So here we have just a generic peroxide. And by now, you should know that peroxide is going to split like this. So each of these oxygens gets one of the electrons from the peroxide bond, the oxygen-oxygen bond. And so now we have a radical species. So we have an oxygen with an unpaired electron. And so that unpaired electron is going to be what actually reacts. So we have here our first monomer of the species that's actually going to form our polymer. And what will happen is the radical electron will come, drew that a little too close. So the radical electron will come together with one of the electrons from this double bond to form a new bond. The other electron will revert to the other carbon of the double bond. And so now we have this species. With our radical located on that carbon. And so what's actually going to happen next is a radical rearrangement. So this is an allylic radical, and so it can rearrange. So we could visualize that as one of the electrons from the double bond coming together with that radical electron to form a new double bond there, and the other electron of the double bond reverting to this terminal carbon. And so that's going to give us this. So our double bond is here now. Our radical is on the terminal carbon. And so from there, and so this should actually be a double-headed arrow, right? Because that's really just a rearrangement. Not even, so it would be wrong to call that a rearrangement, I guess. It's a resonance form. Yeah, so it's an allylic radical. So I guess rearrangement would be the correct term. So it can rearrange like that, and then another of these monomers can react again in the same way that the first one did. So this radical can come together with a double bond electron to form a new bond, and the other electron will revert to the next carbon. And so that will get us to here with a new bond here. Double bond there. And a radical. Right. So let me go ahead and fix that. So the double bond is going to be here, and the radical is going to be up there. And so it's at this point in the reaction that we can actually account for the formation of our two different products. So we have again a radical that's part of an allylic system. It's an allylic radical, and so it can rearrange. So just like before, we can draw it rearranging. Sorry, I need to redraw that. Okay, so if we were to draw the radical rearranging, we would have a situation where our double bond is now there, and our radical is now on the terminal carbon again. And then, of course, that piece can react exactly as the previous pieces did. And so if it were to do that, we end up with the polymer product that looks like this. So there's our straight unbranched polymer that the problem calls A. But we could also have a situation where this intermediate doesn't rearrange. And so I'm going to go ahead and redraw the intermediate here. And then I will just show. So if it rearranges, like we said before, the rearrangement could be conceived of like this. And if it doesn't rearrange, what we can have happen is when our next monomer comes in to react, it will react with the radical where the radical is, since it hasn't rearranged. And so that is going to end up adding to the chain in that position. Now we have a radical there. And so the chain can continue to grow from where that radical is located, but we now have a branch. And so when that rearrangement doesn't occur, we end up with a similar polymer to, well, here I'll label this A as the problem does. So we end up with a similar polymer to A, but rather than being straight chained as A is, polymer B is branched. So there we go. And so that's B. And so, as I said, when the radical continues to rearrange at each step in the polymerization, you end up with A. When it doesn't rearrange and a monomer adds to the secondary radical rather than the primary radical, you end up with branches as a result of that, and you end up with a polymer that the problem labels B. And so that's the answer to chapter 31, problem number 14.